So let's talk upon the very first and the important command which takes into consideration, known as create table. Now, what is the meaning of create? Create means making of something. As I said, a client came to me and they want a database to be created for them. That is, they want the student base to be stored very effectively, very efficiently. So first thing which I want to do is create a database. For them, I will be writing a statement known as create and then something called as database. Now let's see with a syntactical way how the database would be created. So I'll be opening my SQL workbench, and in that I have written that we have 5 commanding languages and DDL, DML. So DDL is an SQL command used to create database schema, that is database layout, and it is used to create or modify the structure of the database object. Now, one thing which you need to know that none of the commands over here are going to be useful or helping the use of where, which means where clause is something which will not be in much use case over here, especially not in drop and truncate. Then you cannot roll back, as all of them are auto committed in nature, which means all the changes are permanently stored. So here what I am going to do is I am going to create a database, as there are 5 commands: create, alter, drop, truncate and rename, and I'll be seeing the very first command, that is create. So I'm writing that I'm creating a database. So creating database named as a client came to me and the client name was Imarticus, let me name the database with that name itself. So I'll be naming the database as Imarticus. So how I will be creating a database? So let's try to see various ways in order to see how a database is created into a MySQL server. For that, as you know, SQL is not case sensitive. So I'll be writing create. Create what? Create database. So I can write in any case, it's fine. Create database. And if I just end the query over here, it's going to give me an error. Why there is going to be an error? Because create database, I gave that statement, but I didn't mention that what is the name of the database. So the identity of the database or the name of the database seems to be missing. So here you can see statement is incomplete. Why it is incomplete? Expecting an identifier. Now what is an identifier? A name with which the database would be known. So what is a name with which the database would be known? Imarticus. So I will write Imarticus. Let me off the caps lock. So Imarticus is what I am creating over here, and I do control enter. When I do control enter, it would definitely be created. How you know that it is going to be created? My output is not there. So here, from here I can get the output. So action output, you can see. This is a command which I ran just now, and create database Imarticus is successfully executed over here. Now, but here in the schemas option, it's not available. Now, many people say, ma'am, the command is executed properly, but I cannot scheme the schema. You just have to refresh. When you refresh, you can see the database is created over here. Now, one another way which people do take into consideration, but it's not required to write the syntax in that manner. Now, let's say I write creating a database PG, known as PGA. Now let's say there is another database which I am creating known as PGA. So how I would be creating it? So another way of writing a syntax, but it's not a mandate part. So create database, as I will be creating a database. So create database, and what I want, if means if not exist. What does it mean? If the database name doesn't exist, then create it. So when you write if not exist, it is expecting a new schema name. Schema name is a database name. So what I am going to give a schema name as PGA. When I write like this and I execute it by control enter, You can see it's executed, and let's say I have created that database. It's not seen. I just need to refresh, and you can see PJ is being created over here. And once again, if I click by mistakenly, you can see what it is showing me. It is showing me a yellow symbol, a yellow icon, which means a warning. Now, when you write if not exist, what does happen over there? That it will create a database if it is not existing, but if it is existing, it will throw out a warning instead of an error that you have created this kind of database. You can see a warning message. Can't create database, PGA database already exists. It does exist when you write. But it's not mandatory to write if not exists. So imagine if I remove this and I execute this code. Can you see the difference between that? When I write if not exists, if it is not existing, it will create. If it is existing, it will give me warning. But when you just write create database and the database name, if it is existing, it is going to give you an error as a symbolic representation. So here you can see it is showing you error, and you can see which syntax is being used over here. So this is how you can create a database. Now there is one more way to create a database without writing any code over here or any of the query. That is from this option. If you can see, create a new schema in the connected server, which means whichever server you are being connected, it will help you to create a new schematic representation. So I click on this, and here you can see name. New schema is a by default name, but I want to give it as data science. Data science. When I give this name, you can see this name is being used. You just have to do apply. Once you apply, there will be okay, that yes, okay, you want to apply. And here you can see create schema data science. It is writing the syntax on itself. Create schema data science, and I do apply. After applying and finishing, you can see a database data science schema is being available into the databases which we had created. Now, in order to show all the databases which are there, you all must be knowing the syntax which we did in the very first part. This is show databases, where it is going to show me all the database names which are available into my server. As you can see, all the database names are there. Now, I would be creating tables into the Imarticus database, which I would like to use. So, what I am going to write the syntax of use. Use what? Use Imarticus. Now, it's not case sensitive, as I said. Anyhow, you can write it. So, I've written use Imarticus, and once I execute this code, now in order to execute, I'm using a shortcut key known as Control Enter. If you want to use this operations, you just have to select it and run it from here or here. This will execute one code. This is going to execute all the selected codes. So here you can see I have used this command over here, and this is being selected. If you want to select data science as a schema, you can directly go over here and double click. It will be selected automatically. If you want to use Imarticus again, double click and it will be used automatically. So here you can see a database is created by multiple ways, and this is how a database is created. Now, after this, let's proceed further in terms of adding the tables which we want to create. We have created a layout. Let's try to add the tables over here. So as we have understood, how does create table works, which means how does create database work, which means we will be able to create a database over here. Now the database could not be empty. Definitely we have to create tables over here. Now what will be the syntactical way of creating a table, and how we will be proceeding further in terms of creating table? What are the key requisites of a table? So here, if you can see on my screen, there is a syntax for creating a new table, which is create table and the table name. It consists of something called as column 1, but it also consists of something called as data type as a mandate part. So column name is fine, but if you don't give the data type over here, it is going to be giving you an error. the table would not be created. The syntax is incomplete over here. So the column parameters, that is column 1, column 2, column 3, specifies the name of the columns in a table, which means it will mention. Imagine the students table needs to be created. So column 1, that is student ID, column 2 is nothing but student name, and so on. So they are column parameters. Now the data type, the next mandatory parameter over here is specifying the type of data the column can hold. In SQL, as it is a relational database management system, it is stored into RDBMS, and relational databases have fixed schema. Now, what is the meaning of fixed schema? They know which type of data would be stored in which column. And that's why it becomes mandatory when you're creating a table to add a column name over there or with respect to the data type. So the data type parameter specifies the type of data the column can hold. It could be varchar, it could be integer, it could be date, it could be anyhow. So we will be seeing how it is going to be created. Now, as I go over here and I follow the syntax, as you can see, create command in DDL is used to create database objects such as DB, tables and views, and I will be creating a table. In that, there is a syntax known as create table, table name, column 1, column 2, column 3, column 4, definition. There is something called as constraints if we require, and then there is something called as engines. As me being a data engineer, I have created a layout. As you can see, the first table which I would like to create is nothing but students. And in that we have column known as student ID, student name, age, city, phone number and gender. So let me write a syntax over here only with respect to column names, and let me show you an error which comes when the data types are not being given. So create table. As you are creating a table, you will write the syntax like this. And what is the table name? Let's say my table name is what? Students. Whenever I write the syntax and close it after this, it's not going to be a complete syntax. Why? Because if you can see, there is no error, but if I execute by control enter, you can see a table must have at least one visible column. Now I'm talking about a table. Don't you think so? A table will have minimum to minimum one column, because a table have information stored in the form of rows and columns. There is no column being created. So a minimum visible one column is required. If you write the syntax like this, it's going to be an error. Just like the create database, the syntax of create table is not the same. It is different. So I did create table, and here in the syntax, if you can see, in order to add a column name, you have to give this parenthesis, also called as a tuple bracket. What is the name I want to give as student ID? The next name which I want to give is student name. Student name. The next element which I want to give over here is nothing but, let's say, age. Then it is asking for what? City. Then it is asking for what? Phone number. And then it is asking for what? It's asking for gender. So this is a column which is being required. If I write the syntax in this particular manner and proceed further, if I am executing the code, it's going to show me an error. Why? Because as we saw the syntax, it requires the column name, that is for sure. But the data type which is expected with respect to each column is also required. Why? Because, as I said, that in a relational databases, it's a fixed schematic where it mentions that what kind of data you are going to insert in each of the column. So if I am inserting IDs, I will definitely expect IDs to be in numeric format. If I'm expecting names, then definitely I want names to be in textual representation. If I want age of the individual, definitely I would be requiring it into the numeric representation. So all those requirements I know, but as per me, I cannot give the database data types. As per the servers or as per the MySQL, what kind of data types are supported into that and what it could be useful. Let's try to understand that over here. So we will be studying the different data types available in MySQL. So in order to maintain the type of data which is stored, as you know, that SQL requires a column name and a specific type of data which needs to be stored. And if you don't give that, the syntax is not complete and it will give an error. The table won't be created. So what type of data types are required over here? So when we talk upon the different types of data, the different types of data which are supported into SQL are numeric, then there are floating values, then there are strings, and then there are date and time related data types which are being used. Now when I talk upon numeric, it is also known as exact numeric. Now what is the meaning of exact? It is not going to consider any decimal element over here. Now what is the meaning of any decimal element? Which means it is not going to consist of 4.5, 2.3, those kind of numbers. It is going to consist of an exact value over here. Now, next one is floating. Now, as the name suggests, floating. Floating means approx. It's not an exact value. So, it can consist of something called as decimals over here. Then there are something called as strings. Now, why there are strings as a data type? As we know, not all information could be stored in the form of numbers. Not all information is going to be in the form of integers and floats. Sometimes the information could be into the form of letters, alphabets, or in case certain times and special characters. So when I want to store them, I would be using or requiring a data type known as strings. And then I have something called as date and time. Now date and time is a data type which is very sensitive in terms of SQL. If you don't give the format in a correct manner, if you don't write the data in the correct format which it requires, the data might show issue, the data might not be stored, or the data nature would definitely change. So that's the reason why knowing the type of data before inserting it into the column definition becomes one of the most important factor in SQL. So when I talk upon integer, or also known as exact numeric data, where it consists of integers, tiny int, small int, medium int, big int, and bit size. Now, as you can see in numeric data, one of the common one which is used is integers. Now, tiny int, small int, medium int, as well as the big ints. Now, what is the size? Size is the number of elements or the number of values or the maximum size a data can hold. Now, in certain of the data types, sizes is one of the most important factor which it comes. So, the type of data and size, the maximum value the data can hold into that column is being given by the size parameter. Now, the bit, the maximum size it can hold is 1. Tiny int, the maximum size of the data it can hold is 255. Small int, you can see the size can range from minus to of this number to plus of this number. There is something called as medium int, where the size ranges are being fluctuating over here. Integer, one of the most widely used data structure, where the sizes are in this particular range. And then there is big int, when you want to store a very big number, then you can give something called as big int. Now, integers or numeric data types, also known as exact numeric data types, they would be helping us to store exact values, not the approximate values. Now, which means this will not consist of any decimal element over here. The next data type which we have is nothing but floating. Now, floating means a decimal, or I can call it as an approx value. Why it is called as floating? Because it's not an exact. It's somewhere floating between two exact values. That is, it's somewhere into the decimal or in a fraction or in a range between two values which are finite in nature. So for that, we have two of the data types. One is decimal and one is float. We will be studying the use case of each one of them over here. Then the major one of the most important one, when the data could not be stored only in the form of numbers or only in the form of strings, only in the form of numbers or only in the form of floats. It will be stored somewhere when the data is apart from something which is numeric. So for that, we will be using something called as string data type. Now in the string data type, two major parts which are there, or two major types of data types which is there. One is known as your char and the another is known as varchar. Now what is the meaning of char and varchar? Let me simplify it over here to you. Imagine that in the string data type, I have something called as char and I have something called as varchar. Now char means character and varchar means variable character which is there. Now imagine that I give char with a size. Now you all must be knowing what is size. Size is nothing but the maximum size of data a column can hold. Now some of them the sizes are fit by default, but for some of them you have to mention it mandatory. So as for char and varchar, we will be mentioning the size. Imagine I give char as 6. Just a second. Imagine if I give char as 6 and varchar also 6. Now it looks similar, then what's the major difference? When I do char as 6, it will create a memory box where each data will be stored in how many characters? 6. 1, 2, 3, 4, 5 and 6. Varchar will also take the maximum length which is there and it will create 6 boxes. 1, 2, 3, 4, 5 and 6. Now imagine that I have a name which is known as Rashi. So when I am storing in the form of char and when I am storing in the form of varchar, let's see, R A S H I. It will be stored in this particular manner. R A S H I. The storage part is same. But what makes a major difference is the way it is stored. Now characters is 6. But still it will expect what? Fixed length character. Fixed length character means if there are 6 characters mentioned or if the char is asking about 6 memory spaces, so even though the value has less than that particular memory spaces, but it is going to occupy all the 6 positions. So this will be also made to look as filled even though there is nothing into that. So char is this way useful. Now varchar, when I know my name is going to flexibly change. So at that time we have varchar. The var over here means variable. That means variable length. It varies the length. It's not going to be fixed length. Imagine you have said 6, but the name suggests 2 characters, 3 characters, 4 characters. It's fine. It will only capture that varying space and the rest of the space will be kept empty or it will be free up so that it becomes memory efficient. So when I use char, when I know my data will have fixed length of characters, I'll preferably use something called as char. When I know my data will have variable length of character, which means changing length, such as your names, your addresses, your email ID, it's not going to be a fixed length. So at that time, you will use something called as varchar. And char and varchar is something which is used by almost all of the RDBMS into the SQLs. So this was about the char and varchar. So when I talk upon char, a fixed length with maximum length of 8,000 characters. As it is said, as the name suggests, is fixed. So fixed length is being there, 8,000. Now varchar, it is not fixed, you have to write variable length. So variable length with maximum length of 8000 characters. So it consists of what? A variable length or a varying length. It's not a fixed length. So there is some mistake which has happened in the earlier part. So just understand that it is a variable length, not a fixed length. Now binary. Now binary, as you know, that binary as a data has a maximum length of 8000 bits, but it has datas into ones and zeros and so on. So where binary, so it has variable length storage with 8000 bits, block for binary large objects, and text variable length storage up to size of 1 GB of data. So these are the various data types in your strings as a data, but not all of them are supported by the servers, but char and varchar is something which are supported by many of these servers into your RDBMS. Now the next type of data which we have is nothing but date and time. Now what is the meaning of date and time over here? Imagine that I want to store when the entry was being made, whenever the task was being done. At that particular time, I want to store that data. So what I could do is I could add something called as date and time. So your date stores the data in a format. Now remember this format very carefully. In Excel, we used to customize the format. We used to change the format of the dates very often, however we wanted. But in SQL, we cannot change the format because the format of the date is fixed. That is YYY, MM and DD. So whenever a date is being entered, it is expecting a format in this way. But when it is having a format anything apart from this, then it is called as a text. It doesn't consist it as a data type. Then we have time. Obviously, a time would also be able to be stored into my server. And in that, the format of time is going to be hours, minutes, and seconds. Now, date, time. Now, sometimes I want to store the date as well as time when this operation happened. And for that, we use an operation or we use a data type known as date and time. So, it stores date as well as time related information in the format of YYYY, MM, DD, and then comes hours, minutes, and seconds. Now, if you see timestamp. Now, timestamp, it stores the data in the second since the Unix epoch. So, it will store the data on the basis of timestamp, that is very similar to the date and time. It will give the date as well as the time on which the data was being stored. And year. Imagine that you just have to create a year related column, and in that you have to store it, the year related information. So it stores a 2-digit or a 4-digit format, but specifically we use a 4-digit format, that is YYYY. It ranges from 1901 to 2155 in a 4-digit range which we can give. So this was a date and time related data types. If you know that what type of data needs to be created for what type of column, it becomes very easy for a data to be created, for a data to be stored, and for a data to be efficiently handled into your server. So as you can see that we understood the types of data which are there, and I know that I want to create a column, create a table name as students, and the columns are being created, but I didn't give any data type, and that's the reason why it was showing me a syntax error. Now let's see how we can overcome those part and how each data type or each column will specify a specific type of data which will help to gather good information over there. So if I go over here, student ID. Now the IDs which I want of the students are integer. Integer means fixed numbers, an exact numeric value. So I will give something called as integer. So ID which I am going to mention or I am going to keep for all the students is going to be 101, 102, 103 proceeding further, and ID is something which is being added. Now student name. As you can see, space could not be added into the column name. So in order to add space to a column name, you cannot use this quotes. This is slightly out of the rule of the data. This quotes which we have seen when you give a value, a text value, this is a quotation which we give, but this is an error. If you can see, it's not valid and this position. It is thinking of it as a value, but it's not a value over here. It's a column structure. For structure, now what is the meaning of for structure? Which means for table name, for variable names, for your column names, anything, or database names as well. For structure, we will use a backquote over there. Now, where do you find it? You all must be having an escape button into your laptops, and below escape button, there is a small S symbol known as a tilde symbol. And with that, you can have a slight dash which is in backward position. So backquotes would be used. If I click on that and then I click on that, you can see this is how a space into a column name or space anything related to the data structure is being, or a data structural part is being stored. So student name is something. Now name of the student. What type of data do you think so I should use? Now obviously a textual data over here. Now in textual data we saw that there is tiny text, medium text, text, blob, binary, varchar, char, binary char, var binary, many things are there. But I will choose and go with a very basic approach which most of the people do choose, is something called as varchar. Now why I am choosing varchar? Because I don't know that my student names are going to be fixed of 10 characters, 20 characters or 30 characters. They might be varying. So the lengths might be varying and the storage will be efficiently handled if the varying character database would be stored. So I will give something called as varchar. Now when I give varchar, it is expecting one thing with me, that is size. Now size over here is mandatory. That is how many variable length of characters you are expecting. The maximum length which you will expect over here, let's say I give 25. So the maximum length which is expected is 25. But if any name falls below this particular range, it will manage the storage. But if we would have used char with a character of 25, so for each name it will expect 25 characters, and if those are not being mentioned, the memory is still not going to be helpful for other datas, but it's still going to be kept for that particular 25 characters data element. So it will be of fixed length, but I know my student length is going to be varying length. So I have given varchar age. Now obviously the age of the individual is going to be what? An integer. So I have given an integer over here. Now city. Now I know city is going to be what? A textual data. Now cities such as Mumbai, Chennai, Pune, when I enter, it's not a number. And it's not in the form of any exact or decimals. It's in the form of strings. It's in the form of characters. And if I want to do that, I will choose to give char or varchar. But I know that my data consists of a variable length of data or variable length of data points. So I'll give 30 as a varchar. That is a varying length. Then here you can see phone. So phone number, definitely I will think of it as an integer. But my phone number will have 10 digits, 11 digits and so on. Mostly so 10 digits which could be kept over here. And I will write something called as big int. Big int means a bigger range of integer would be considered over here. And then I have gender as a column. Let me give a char over here. And gender as male and female. So male will have 4 characters and female will have 6. Let me give a variable character of 6. Now you can see the table creation will not show any error and it will be executed very smoothly. But one thing to note, imagine I have not executed the code so far. So imagine the table is being created. Imagine the table is being created and I started entering the data. Now it's just imagine I started entering the data and I inserted 101. Student name is Raj, age is 23, city is Mumbai, let's say phone number is something over here, gender over here is let's say male. Now 101 and in that there is something called as Sam. Age is missing and city is Pune. Then phone number is something over here, and this is also what, a male. Now there is 104 and the name is Rashi. Age is 25. Let's say the city is Mumbai, and the phone number and gender is missing. So let's say if I enter one more record and I didn't pass any name and I passed in an age of -4. I didn't pass any city, I passed a phone number which is repeated over here. And here you can see male and I didn't mention anything. So when I'm entering this data according to the data types, in student ID I asked integer, in student name I asked varchar, in age I asked integer, in city also varchar, phone number big integer, bigger number of integer, and gender, if you can see, males and females are being considered. But there is one more problem, that is the data is not effectively stored. If you can see at some position the IDs of the student is duplicated. Can the IDs of the student be duplicated? Each student will have a unique ID. But in this information which is being stored, you can see a duplicated entry being possible, which means there is some error in only with the data type. The data type is correct, but when we just mention data type, we are not applying any rule or any limitation that it should only consist of unique elements, it should not consist of repetitive elements, and so on. So here you can see there is some issue. Now when I go with student name, you can see student name Raj, Sam, Rashi is there, but the another student name is what, missing. Do you think so student name missing for any of the individual will be fruitful for my data? No. So age is missing of one of the individual, but there is one age where the age is filled, but it's not with appropriate value, that is -4. So age of any of the individual is not going to be -4, it will be some or the other value. City missing. Phone number, you can see it shows a duplicate entries which are there, and then gender seems to be missing. So there were problems faced when I was creating a table and then storing it directly as it is with just mentioning the data types. It will still bring the chance of error into the data if you just write a create table with only the data types which are there. So in order to overcome these errors and in order to mention SQL to take a very specific data to set up a rule or limitations to the data being entered, we will use something called as constraints. Now, what are constraints? Constraints are nothing but the rules that we can apply on the type of data in a table, which means, as you saw with an example, student ID was repeatedly there, student name was missing, the age was in wrong value. So all those errors I want to minimize, and in order to do that, we will implement the rules known as constraints. Now that is, we can specify the limit on the type of data can be stored in a particular column in a particular table using constraints. Now in SQL, there are many constraints which are available. The very first you can see there is unique, then there is check, then there is not null, then there is default, then there is primary key, then there is foreign key. So these are certain constraints which are available into the market. Let's understand each of the constraints. Now the very first constraint which I talk upon is not null. Now first of all, understand the meaning of null. Null means empty, null means vacant, or null means missing. So whenever any of the column has empty values, empty rows, or empty data points or vacant data points, which means null is being considered, that is emptiness being considered. But there are certain instances where I want this emptiness to be eliminated. I want to keep that column information to be mandatory. And for that, I'll be using something called as not null. Null means empty, that is the value is not available. Whenever a table column is declared as null, whenever you create a table and one of the column you declare it as not null, then the value of that column cannot be empty for any of the table records, which means for any of the row, that column should not be empty. That column should not be having any emptiness or the missing elements which are there. There must exist a value in column to which the not null constraint is applied, which means it will definitely ask you to implement some or add some or the other value before proceeding further, or else it is going to give me an error. Now, one thing to note, many people think that if I write 0 instead of data, which means that is also null. No, 0 is a value which is being considered. Null means it's completely empty. That position is completely empty. It's non-zero. It's missing. So null does not mean 0. Null means empty column or non-zero. So let's see with an example on the column which is created, and which column do you think so we can add it as not null. So if you go over here, let me erase the data which we have stored. So this is what we have stored, and let's talk upon the constraint known as not null. So which column do you think so in the created table would be consisting of not a null value? Let's say IDs. IDs of each student needs to be what? Filled completely. So I will say that yes, an ID could be not null. Student name. Yes, the student name of each of the student is mandatory. It's not fair that the student ID is there, all the details are there, but the name is missing. Name is something which is need to be available for each of the student, which I want according to my consumption. So I can mention the student name as not null, that is fine. Now age. Now many people, the old age peoples, they don't know their ages. They just randomly put in some values. But age of an individual, if you need to keep it as mandatory column, then you can add not null. But as of now, student ID and student name do require not null as a constraint. Now one point to remember, not all the columns require to have constraint. Only certain of them can have constraint and certain can have only data types. It's fine. So age as a column, I'm not thinking to add any constraints as of now. Then I have city. Now city as Mumbai, Pune, Thane, Nashik, so on. So there are cities. Do you think so that each student city name needs to be there into my table? If it requires to be there into the table, then definitely I will add a not null constraints. So make that column entry to be mandatory. Then phone number. Now some of the students have not implemented or not having phone numbers with them. And that time I might not keep it as not null. Why? Because some of them doesn't consist of it. So it doesn't make any sense by adding not null over there. Then comes gender. Now gender being a mandatory part, that are you a male or a female? So that will be helpful for us in terms of filling. So not null, as we saw, student ID and student name not null constraint. Student ID and student name as a column requires not null constraint a lot as compared to the rest of the columns which are there. So we understood that when or where we can think of using not null and what is the meaning of not null as a constraint. So as we saw over here, that how a not null constraint could be added to certain of the columns and how a not null constraint could not be added to certain of the columns. For me, student ID and student name, where I want those fields to be mandatory available, and that's when I'm thinking to add not null as a constraint. But for others, it's not mandated that all the columns should have constraint. So we understood things about the not null constraint. Now let's see what are the furthermore constraints which we have. Now after not null, the another constraint which we have is nothing but unique. Now what is the meaning of unique? Unique means each value should be unique from the another one. That is the simplest English definition which we know. Now the same definition would be followed over here. When I have duplicate values, it would not be allowed for certain of the columns. Let's say I have IDs and that could not be duplicated in nature. Let's say I have phone number and I want all the phone numbers of all the individuals to be there as unique. So duplicate values are not allowed in the columns in which unique constraint is applied, which means wherever you apply a constraint, a rule named as unique, which means a duplicate entry or a duplicate column or a repeated data would not be allowed. So the column with the unique constraint will always consist of a unique value. So with a unique constraint, all the columns are, all the values of that particular columns are going to be unique. Then this constraint can be applied to one or more columns, which means it's not mandated that you will implement unique to only one column. You can implement unique to multiple columns in a table. So you can create multiple columns on a single table as unique constraint. Now, unique does not mean null, would not be considered. Now, what does it say? That when I say unique as a constraint, I have never mentioned that not null would be a part of it, which means if the null value is there, it will be stored. There is not going to be caused any error if you have a missing element into a column where unique constraint is applied. It will consist of null. So unique does not mean null would not be considered. Unique can store missing values, which means if you implement a constraint known as unique, it can store missing values over there. So let's see from the table which we have, which of them could be considered as unique. So the next constraint which we would like to talk upon is something called as unique. Now, in the unique as a constraint, the first column, that is student ID. Now, when each student enroll into the organization or enroll into the platform or the learning environment, I want the student ID of each or one of them to be stored in a unique manner. Which means if I being a student to the organization, my ID would be 101. If another student is there, then his or her ID would not be matching with mine. It will be either something apart from 101, it could be 102, 103 or so on. But none of the student's ID is going to be repeated. Then yes, I will consist student ID implementing something called as unique as a constraint. Now student name. Now I cannot mention or I cannot use unique as a constraint to student name. Why? Because many of the students can have same name. Now in my class, if there are 4 students named as Raj, that doesn't mean that that is not a true value. That is a true value because many students can have repetitive elements. And if I implement student name as unique as a constraint, the data would not be effectively stored. So that is one thing which we need to keep in focus, that unique constraint could not be considered in names. Ages, obviously age would not also be a unique constraint. Why? Because many students' age are going to be a matching age. But unique, as it consists of each row of unique values, I cannot mention ages as unique because it will expect each student to have a unique age. And that's not true in the real world scenario. Then I talk upon city. Now city means what? City, certain cities from which the students are coming. Now some of the students can come from same cities, some of them can come from different cities. So same city values are also being possibility available over here. So I cannot implement unique as a constraint over here. So unique is also not being a part with the city as a column. Now phone number. Yes, I would think of phone number of the individual to be unique from the other one. So phone number could be acted as a unique as a constraint. Now gender, definitely I'm going to use 2 genders over here, that is male and female. And unique as a constraint could never be used into the gender as a column. So as we saw that student ID and phone number might be kept as unique with respect to the values or the data discrepancies which we want to avoid. So student ID and phone numbers can be a part of a unique constraint. So this is how unique would be there. But one thing to note, that unique doesn't mean not null. Unique can also store null value. And not null doesn't mean unique, which means it just wants the value to be filled. It can consist of duplicate or repetitive data. If you are mentioning only not null, it can consist of duplicated data. When you are mentioning only unique, it can consist of null values as well. So this was about not null and unique as a constraint. Now let's talk upon another constraint which we have into consideration is nothing but primary key. Now what is the meaning of primary? Now primary means important. One or one of the major important column of a table or one of the major important factor of a table. So when I talk upon primary key constraint is nothing but a combination of not null and unique. So it will have properties of not being null as well as a property of being unique. Now not null constraint and unique constraint together forms what? A primary key. Now, the column to which we have applied the primary key will always contain a unique value and will not allow any null entries into it. Now, in a table, you should note there can be multiple unique columns, there can be multiple unique constraints added, but there is only one primary key column. As I said, primary means main, important, and it is only going to be one. So one primary key is more than enough for the table to add uniqueness. One of the definition for primary key is it adds uniqueness to each row in a table, which means each row unique from the another one. So that's how primary keys are there, which is a combination of not null and unique. Let's see with our data which column could be taken care of as a primary key. Now in my table, the next constraint which I would like to give is nothing but a primary key. So I'm writing a shortcut over here known as PK, that's primary key. Now which column do you think so can act as a primary key? Now primary key, whenever it's said, it is said that it will consist of not null plus unique. That it is consisting of non-null values, but all the values over here are going to be unique. So let's go to student ID. Yes, if you see in the not null and unique as an example, we saw that student ID we can implement not null constraint, in student ID we can implement unique constraint as well. But if I just implement not null, which means imagine that I write not null over here and it is trying to insert a data. It is just expecting me to not implement null values over here, but it can allow repeated data when I just use not null as a constraint, which means it can allow repeated data to me. As you can see, 101 and 101 as an ID is being repeated. So only use of not null is not being useful for us. Now, if I say that apply unique over here, so if I say student ID, as we discussed, that student ID can be, just a second. Let me minimize it. As we said, that student ID can be a unique value. So if you only implement unique as a constraint, what it is going to see? So unique doesn't means null. So here if I implement 101, 102, but if I don't put any ID, it will accept it if I just use unique as a constraint. So in ID, even though I can use not null, even though I can use unique, but I will think of using a primary key over here. But I'm not using primary key directly. I can think of using a primary key. So primary key could be created over here. That is one of the column where a primary key could be added. Why? Because I want the IDs of the student not being null, also at the same time being unique. So that's one column where I can think of adding a primary key. Now student name. No, I cannot add student name as a primary key. Why? Because a student name I can implement not null, but I cannot keep it as unique combined with not null. So I cannot use student name as a primary key. Age, same reason that I can write age to be mandatory, but I cannot say that age is always going to be unique. City, same, I want cities to be there as mandatory, but city names are going to be repeated for certain of the students. Phone number, yeah, I can think of it as a primary key. Why? Because if I say that phone numbers are mandatory, then it's a mandatory column. And if I say that phone numbers should be unique, then all the phone numbers must be unique. So I can think of phone number being a primary key. So this column can also be thought of as a primary key. And gender, definitely it cannot be unique. Not null could be added, but it cannot be unique. So two columns where there is a requirement or where it can act as a primary key is my student ID and phone number. But as said, you can have multiple columns as unique, but you will always have one column as a primary key. Now, which column do you think so among student ID and phone number is going to be a primary key? Student ID over here has high chances of being primary key. Why? Because one thing to remember that each student is going to have a unique ID, and that is not at all going to be repeated, and it is mandatorily be created. But some or the other instances, if the student's phone number is not available, the student might not enter the phone number and it might have a possibility of being blank. But amongst the student ID and phone number, one of the column where I can think of adding a primary key is going to be student ID. So I'm going to choose student ID as a primary key to my table. Why? Because it will have a possibility of being not null. At the same time, it will also be unique. So here, as said, in a table, you can have multiple unique constraints, but you are only going to have one primary key. And that one primary key is more than enough to make sure that each record is different from another. So even though 101 and it has a name as John, 102 it has name as Eric, and there is one more student who is named as John, and the entries are being given. But this is making sure this both the Johns are different from each other. Why? Because both the Johns IDs are different from each other. So this is how a primary key can mention that each record in a table is unique from the another one. So that's what a primary key is, and it is always going to be one. So we will create one primary key in our table. So as we have discussed about primary key, let's talk upon another key which is there, known as foreign key. Now what is the meaning of foreign? Foreign means something which is coming from outside. So definitely, as we have tables which are being stored, or as we have information which is being stored in different tables, and we sometimes need a column coming from a different table in order to help us to store the data effectively. And that's when foreign key as a concept comes into consideration. Now, whenever I'm talking about relational databases, the word relational, that relation part would be denoted or would be helpful or would be created with the help of foreign key, because another table or an outside table will help you to relate with the main table which you have with the help of foreign key. Now, foreign key is used to maintain referential integrity. Now, what is the meaning of referential? Referential means relation, and integrity. Integrity means same throughout the value or same throughout the data. We will be discussing in-depth analysis of referential integrity, and I'll also be showing you with a practical implementation as well as a theoretical implementation of what is referential integrity and how it needs to be maintained in the table. So when I talk upon foreign key, it is coming from outside to one table from another table so that it can create a relation amongst them and the data could be effectively stored. There is no data discrepancies which is being allowed over here. So A foreign key is used to maintain referential. Referential means relational. Integrity means same throughout the data. So the data in multiple tables should follow a same nature. What is that same nature? We will be discussing it further. When we have two tables and one table takes reference from another table, which means when we have two tables taken into consideration, one table is taking relation or reference from the another table, the same column is present in both the tables, which means the column is used to maintain a referential integrity. So they require a same set of column, not with respect to name, but with respect to the values or the data type which is stored within them. So the same column is present in both the tables and the column acts as a primary key in one table. Particular column will act as a foreign key for another table or from a different table. You can create multiple foreign keys. Now this is one of the important questions which comes into interviews, that how many primary keys do you think so could be created and how many foreign keys do you think so could be created. You can create one primary key, but you can create multiple foreign keys. Now let's see with an example how we can create a foreign key. As you can see, I have table named as students and I have table named as courses. Now definitely the students who have enrolled into the organization would be a part of the course. Now the students and course tables have relation with respect to each other based on the student IDs. Now here I have student ID, but here I have only ID. If I want to say that this student ID is being referred for this student ID, so the relation needs to be created. Now, from where should we add a foreign key? Now, as I said, if the student has enrolled, which means the main information which is required is a student's table. So in the students table, if the student has enrolled, then and only then a course could be allocated to that particular person or that particular student, which means students table is a main table and course table will be created after the students are being filled. So the relation or the ID over here needs to refer, needs to maintain a reference from the students table, which means it will first look into the students table. If the ID is available, then and only then that student is going to get the course. So this is how a reference needs to be created. So I will say the reference would be created on the basis of what? On the basis of IDs which are there. Now you can see the column names are different, but the data type which stored between both of them must be what? Same. Then and only then a reference could be created very effectively, very efficiently. So I will mention this part as what? A foreign key. So this is a foreign key and there is a primary key into the table. Now remember, when a relation is created, one foreign key will relate to one primary key. So that is a mandate part which is required, that a foreign key from one table will relate to the primary key of another table. So here you can see a relation is being created where this table is referring to the student's table. That's why foreign key is being created into the course table, because this IDs will only be present only when the student have enrolled. So foreign key is referencing. The referential integrity means references, relates to the student's table in order to allocate the course. This is a foreign key. This is being created. Now, as you can see, I have course as well as course info table, and in that what could be the foreign key and a primary key relation. Now, course info means the information related to the course. Imagine Imarticus is selling 5 courses. Course 1, course 2, course 3, course 4 and course 5. Now, if the course details are been made, then and only then the student could be allocated to that particular course. So here the course details as a primary key. which is it's a main table from where the courses will be allocated to the course of the students. So a table can have multiple foreign keys, but the relation between the tables will be made from one primary key and one foreign key. This is how a relation is being created from the foreign keys in order to maintain referential integrity. We will be understanding what is referential integrity in the further part with the practical demo, so that you will understand those concepts very clearly. So this was a foreign key. Now let's talk upon the next constraints which are there, which could be helpful for us. Now the next constraint which we have is nothing but check. As the name suggests, check. Check means validate. Now validate what? Validate the answer or the value being entered into the table. So whenever a check constraint is applied to a table's column, the user wants to insert the value in it. Then the value will be first checked. Checked means validated. If it satisfies the given condition, then it will be inserted. If it doesn't, it will throw out an error. So then the value will be checked first for certain condition before inserting the value into that column. For example, if we have an age column in a table, as we know that we also have a age column in a table, then the user will insert any value of his or her choice, as we see earlier or as we saw earlier when the data was being inserted. -4 as an age was inserted, 0 sometimes could be inserted because we just give a data type as integer. Now integer could be minus of any number to plus of any number. So we have to be very careful when the age is being inserted. So the value of his or her choice. The user will also enter a negative value or any other invalid value. But if the user has applied check constraint, which means if me being a user and if I apply a check constraint on the age as a column, then the condition must be greater than 18. If I say that the student's age must be greater than 18, then I have some validity to be applied over there. Then in such cases, even if the user try to insert any invalid value such as 0, any other value less than 18 or even a negative value, then the column will not going to accept the value and it will not allow user to enter, but instead it will throw out an error. So this is how check as a constraint could be applied, which will help you to validate or which will help you to keep the validations over there when the data is being inserted. That is a check constraint which we have. And let's study about the default constraint and let's see how we can implement that as well, both together. Now default, as you know, by default. Now what is the meaning of by default? Which means if something is not possibly there or something is not possibly found, then by default use something else. That is what we know. So imagine if the student has forgot to enter his cities or forgot to enter his address and so on. Now I know that is something which I want it to be there when the value goes further or when the data proceeds further for further analysis. But if the student has not entered anything, then it is expecting or it is being null. But I don't want null to be stored. So do I want to replace that null with any of the other value or any of the by default value? That's when default as a constraint could be helpful. When a default constraint is applied to a table's column, then the user has not satisfied the value to be inserted in the table, then by default it will take that value which is specified by the user when the value was not found. That is what a default constraint is going to take help over here. So imagine that I have a table and in that we are storing some information which is there. And I would like to see that which column could have check constraint and which column could have default as a constraint. So when I want to implement check, now definitely I'm not going to take help of student ID in order to implement check because I don't want to check anything or I don't want to validate anything over here. Student name, I can say that the student name is consisting of R, starts with S, but I'm not going to think of over here because student names can start with any of the characters and with any of the characters which are there. Age, definitely when the student age is being entered, I want the age to be between 15 to 30, or let's say 20 to 25, 30 to 35. So I will have a limit that this many age of students could enroll into the organization. If the student is not falling into that particular range, then he or she might not be able to enroll. So that age as a criteria where I want the validity to be there. City, I don't want any validity over here, because city name should not be there, or city name should have some condition, which is fine. Phone number, yes, I can implement where the length of the phone number is 10 digit and so on. So that kind of things could also be implemented over here. Gender, I can say I can implement a validity where the gender is either male or female. So I can have only those values to be added into the gender part. So that is how check constraint will be helpful for us in order to keep the validity to each of the column. Now when I talk upon default as a constraint, now what does it mean? Default, which means when you don't enter any value, what should be a by default value considered? Now student ID, yes, definitely student ID is going to be entered because it's a primary key, not null and unique. Student name, yes, I want student name to be not null, which means it's a mandatory part to be there. Age, let's say age of the student, it's available, and if student miss out to enter the age, I'll give a minimum age, that is also fine, which I can implement. City, yes, if the student has not mentioned the city but I don't want a blank to be stored, then I'll keep a by default city as Mumbai, Chennai, or anything as such. Phone number, I want phone number to be there. If it's not there, I can write 0 or not available. And then gender, I want the gender to be there. I don't think so default gender could be set over here, so I'm not going to set any default gender. But yes, for age, for city, for phone number, I can implement a default value, which means if the user forgets to mention some data, so when my data is going into the database, it's not going empty, it will have some or the other by default value instead of null. So this is how constraints could be helpful for us in terms of adding some valuable information to the column so that the data is stored without any discrepancies, it has a proper usability, and the data is stored effectively and efficiently in order for further analysis. So we will see how they will be written into our codes. As we saw the constraints, how we can practically implement it over here, let's see how we can implement into our code which we have created. And let's create a table which we have to do over here. So as you can see that I have given student ID as an integer. So I'll give a space and then I say that the student ID, because we have decided that ID is going to be our primary key. So I'll add key over here. So student ID, in that primary key is going to be that. And one more extra part which we can add in primary key is an auto increment, which means whenever each record is being added, I don't have to mention the IDs of each one of the student. It can automatically increment when the data is being inserted. So that is one of the advantage which will allow us to get unique entries as well as not-nut entries as well. So I will implement something called as auto increment. So I've added something called as auto increment. Now one thing to remember, when you have primary keys, auto increment is one of the useful part which you can add. Why? Because it will make sure that each entry which is being inserted will get one particular value which is unique from the another one. It will increment accordingly. It will increment automatically where you don't have to put any manual entries of your IDs over there. So I have written auto increment. Now student name. Now which of the constraint do you think so? Should I add to a student name? I think so that student name cannot be unique. It cannot be a primary key because primary key is supposed to be 1 and that's done. So it cannot be unique. It cannot be a primary key. Second is I don't want to implement any check constraint over here. Definitely it is not acting as a foreign key for any other table. And then if I want to look out default, I don't have any default names kept. Like if the student name is not available, keep his default name as Jay or Rahul, anything like that. No, I don't have anything such. over here. So I'll simply keep it as not null, which means I want each student name to be at least there. So not null. And then age. Now let's say age is going to be integer, but one thing which I want to use in terms of age is nothing but check as a constraint, which means when the age is being inserted, the age of the individual should be greater than 18. The age of the individual must be greater than 18, which means it's an edtech organization. And he has mentioned that the students who enroll into the organization should have some age limit that is greater than 18, but less than 40. So it is between 18 and 40. So how to implement that? So we will write check. So when we write check, we have to give a condition. Now many people do mistakes in terms of giving check as a constraint. So how do you do over here is we write age. You have to mention that which column you're implementing check, even though you're writing it besides. So check age. Age should be what? Between. Now the constraint which we used or the condition which we used in my where clause, the same kind of condition I'm going to use over there. That is between. Between what? I want the age of the student to be between 18 and 40, which means if the student enrolled is between 18 to 40 as an age group, he or she can enroll. If the student is something apart from those ranges, it is not going to be an acceptable value and it is going to throw us an error. So here you can see a table is being added with age as a constraint, check as a constraint, that it needs 18 to 40. Now what I want over here is city. Now in city, what should I keep as a constraint? Should I keep not null? Should I keep unique? No, I cannot keep unique. Should I keep a default? Yes, I can think of choosing a default. Can I make this primary key? No, there is no another table which I can build up a relation. So as of now, no, this is not acting as a foreign key. Then can I keep it as a check constraint? Yes, I can see check a city is this or that, but I'll not choose. I'll choose something called as default over here. So I've kept it as default. Now when you write default as a constraint, many people write this and end up the query. But what is your default value? Did you mention it something like that? No. So if you can see an error, it's not valid and default position. It is expecting something. Are you expecting a date over here, a time, a value, or anything? It is expecting, but it is not expecting only default. Because default value, what? If the city is not mentioned, I'll say the default city over here is going to be Mumbai. So, a Mumbai is being mentioned if the city is not found. Now, phone number. As I said, it's not mandatory that for each of the column I implement constraint. I will implement constraints only and only when I need a requirement of constraint in that particular column. So as of now, I'm not adding any constraint into it. But when we use alter, we can definitely modify the existing data tables or database object which we have created. So we can definitely modify it further if we require. Now gender. Now gender, as I said, that I want gender to be there as a mandate part. So can I implement two constraints together? Yes. I can write check. I can write check. Check what? Gender. And I can write in. Means the gender is in either male. Means it consists of either male or it consists of something as female. So male or female. So here you can see these are the two brackets which are there. This bracket is for the in condition, the in criteria, which means it can be either male or female. And here you can see this bracket is for check constraint. Now there is an error over here. Why? Because this bracket is not closed. So I'll close this bracket and the error is gone. Why? Because see, you have to be very careful with brackets. This bracket is the list of values you want to check in the gender. This is the gender bracket closing, and this bracket is for your closing of the table creation. You can see When you click on it, there is a yellow symbol. When you click on this, there is a symbol, which means it starts from here, closes till here. When you click on this, you can see this one, when you start from here and it's closing here. So brackets are something which is very important. Now if you see, constraints can be added directly at the end also, but we have added just with the column names, and that's fine. Can you see something over here known as engine name? An engine. Now why do you need an engine? I have not executed this code still. So I'll show you engines. So show engines. So there is a syntax to show engines. Now what are engines? Engines are storage engines which are possibly available into our server. So when I execute this code, you can see that there are multiple storage engines which are possibly available, and you can see the by default engine over here is INODB, and this is the one which we prefer the most. Why? Because it is going to support all the transaction related operations, all the save point related tasks for us. So if you do wrap cell content, you can see support transaction, row level locking, and foreign keys. So this is a storage engine which is going to be supportive for many of the tasks which are required to maintain the relational databases and the integrity between them. And that's how I'm going to use it. So here, even if I don't write any engine, by default it is going to go into INODB. But if I write engine, then you have to mention INODB over here. And if you don't even mention it, still fine. Default, it is going over there itself. So the code is being executed, and if you see over here, create table students, it has effectively been created. It's not available over here. I just need a refresh, and you can see a table is being created named as students and the column names which I give. The columns, you can see student ID, student name, age, city, phone number, gender is being possibly available. Now imagine you wrote this syntax and your file got deleted, but your table is being stored into the server. You want to see what was the code which MySQL actually executed or which I used in order to create a table. So there is one more syntax which you can use, that is show create table. So what does it do? It does show you the syntax which was used to create the table. So if I write show create table known as students, you can see it is showing the syntax. You just have to click on it and wrap cell content. So if I show this code ahead, just a second. If I show you the syntax, you can see student ID int, not null, auto increment. How backend has understood your code and stored it into the server. Student name, varchar, not null, this, that. Can you see primary key has been added below? Constraint student ID, which is a check constraint. Then constraint this, which is another check constraint which you have implemented over here. What was the engine being stored, character set, everything. So how SQL has stored your table, what was the syntax being used. If you want to use this part ahead, you can definitely use it. You can copy it and use it for your further task. So this is how the table which you created has been stored. Your query has been stored, and whenever you want to check the create table query, you just have to run and execute this code, and it will definitely show you the create table query over here. So and this is how the table was being created, and this is how we can view the syntax for create table. What if I want to see what kind of description is there into the table? So we have a syntax known as describe what? Describe students. Now I know I will be describing the tables into the particular database. So describe students. So when I do describe, it will give me descriptive statistics. Now what is descriptive statistic? Just a basic description at the layout. Now student ID as a field means column. Type, what type of data does it hold? Integer. Null, does it hold null? No. Does it hold any key? Yes, it holds a primary key. Default value, is there any default value set? No. Is there any extra element set? Yes, you have set an extra as auto increment. Student name, does it hold varchar? Yes, as a data type. Does it hold no null? No. Key? No. Default value? No. Age, if you see integer, I have not implemented any not null constraint in age, which means does it consist of null value? Yes, by default it does consist of null values. Is there any default? No. City, varchar, null values, yes, but if there is null, what will be the default value set as there? Mumbai. Phone number, begin, null, yes, default value, no. Type, gender type is char, null values, yes, it does consist of that. So here you can see we found the describe of the table, the layout which we created, just to understand the generic part, that what is going to be accepted and what is not going to be accepted over here. Now after this, let's see that how a table from outside could be added into my database over here. Which means if I have a CSV file, if I have an Excel file, how I can add into my system in order to store it as a table. So for that, we have this option. So in this, I just need to right click. When you go on tables, you just have to do right click. Just a second. Right click and you can see there is an option of table data import wizard. Wizard will help you to import the data quickly from a self-contained file. So you just have to click on it. Now you can see table data import allows only easily import of CSV or JSON files, which means you have to be very careful in terms of creating tables from a table or a value which is outside. You need either a CSV file or a JSON file from the data files. You can create data destination table on the fly, which means with certain clicks you can create it very easily. If I go on browse, now in browse it will expect or it will ask for any CSV files available into my system. So downloads, if you can see there is one CSV file which is available and CSV files will only be shown over here. There's another CSV file which is available. So let's say I'll take this CSV file known as advertising and I open it. This is just a random part which is there. I'll definitely drop this table ahead. So you can see users, admin, download, advertising and CSV. I have took the path of the data. I just have to go next. In that next, it will ask for use existing table, which means if you want to use it in the existing table or if you want to create new table and then add it, so that could also be done. If you can select this drop table if it exists, which means if the table which you are creating, if it exists, then you want to drop it, you can drop it and then create a new one. But I don't do it. So next, here you can see when I'm inserting unknown column. So it is given as what? My unknown column 1. The column name was not there, so it has kept it as my unknown column. And integer. Now TV. If you can see TV as a column is there and then there is decimal. So they have considered what? The data type as double. Radio, it consists of decimal, double, double, double. If you want to change the data type, you can definitely do it, but we preferably not choose to do it over here. Then I do next, and in that next, it will ask you to prepare the data for import or import the file. Let's say I do next and I ask it to import. Now you can see once that bar is coming, if it is finishing, it will finish the performing task and click on continue. So it's being finished. So I'll do continue. How many records are being imported? 200. And I do finish. Here you can see I can just do refresh and you can see advertising as a table is being available. So what I can do is I can write select star from advertising. And you can see the table which was there into my CSV file has been loaded into my MySQL server. So this is how creating table could be quickly done if you have a CSV file of the tables pre-created into your systems. So this is how create table has worked with the syntax as well as with this. The table which we created with the syntax didn't had a value like the advertising table. Why? Because the layout is what we have created. We have not inserted it as such. The CSV file has data already being stored, and that's why it does consist of values. So select star from students. If we try to do it, it is just going to show you the layout, that these are the columns being created and this is how you are going to fill in. These are the layout which is being created. You just have to fill in the structure. So this is known as structure being created. And as we are doing DDL, it is purely dealing with the structural part of the data. So this was all about the create databases and tables. Further on, we are going to study and understand the difference between a primary key and foreign key, and let's understand the referential integrity in more detail.